Alright, so, sorry, y'all will flip flop, y'all will turn and they'll say, and they'll do what they're learning today. So anyway, alright, we've been writing equations, we've been writing inequalities, we've been solving things. I mean, we worked on solving the equations and inequalities yesterday. So now, we're going to talk about, you did systems on Tuesday, where you wrote the two equations and the two inequalities, but we didn't solve them. You just wrote the two equations and inequalities. So then we're going to work on the linear inequality graphing. Alright? The first thing, just as a brief introduction, we're going to go to, we're just going to watch this one very quickly. It's a short video, I think it's like 5 minutes long. Come on. No, you don't have to take notes on this. Just pay attention to it. What is the deal? Do what? Yeah, Khan Academy, we watched them in here. Okay, I'll just send her down on that. Okay, all right, see you. Okay, we need to go to the meeting here with your conference. Where are we? Okay, here we go. Here's what. Kyle, you do understand that every time you say that sucks, it's being recorded.
And above the green magenta line. Graph the solution set for this system. It's a system of inequalities. We have y is greater than x minus 8 and y is less than 5 minus x. So let's graph the solution set for each of these inequalities, and then essentially where they overlap is the solution set for the system, the set of numbers that, or the set of coordinates that satisfy both. Let me draw a coordinate axis here.
All right, so what you're getting ready to do today is you're going to graph two inequalities. They'll either be in slope-intercept, like these are, or they're going to be in standard form. He doesn't do a standard form, and we'll do one of those here in just a minute. But you are going to be graphing the slope-intercept form of the equation. You really need to be paying attention.
So that is my x-axis, and then I have my y-axis.
It takes too long drawing the axis.
Boundary for this my y-axis, and now let me draw the boundary line, the boundary for this first inequality. So the boundary line is going to look like y is equal to x minus 8, but it's not going to include it because it's only greater than x minus 8. So let's just graph x minus 8. So the y-intercept here is negative 8. When x is 0, y is going to be negative 8. So let's go negative 1, negative. Two, 3, 4, 5, 6, 7, 8. So that is negative 8. So the point 0, negative 8 is on the line. And then it has a slope of 1. This is the, you don't see it right there, but I could write it as 1x. So the slope here is going to be 1. I could just draw a line that goes straight up, or you could even say that it'll intersect if y is equal to 0. If y were equal to 0, x would be equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And so this is x is equal to 8, and it has a slope of 1. So every time you move to the right one, you're going to move up 1. So the line is going to look something like this. And actually, let me not draw it as a solid line. If I did it as a solid line, that would actually be this equation right here. But we're not going to include that line. We care about the y values that are greater than that line. So what we want to do is do a dotted line to show that that's just the boundary, that we're not including that. We're not including that in our solution set. Let me do this in a new color. So this will be the color for that line, or for that inequality, I should
So
say.
why is he doing a dotted line?
So that is the boundary line, and this says,
Do what? Why did he draw a dotted line, not a solid line? Has nothing to do with greater than or less than. Why is it a dotted, not a solid? We've gone over this. What? No. What is it missing right here? What is he pointing to right there? What is not underneath that greater than sign? And equal to. That's why it is not a solid line. It's a dotted line. Pay attention.
y is greater than x minus 8. So you pick an x, and then x minus 8 would get us on the boundary line, and then y is greater than that. So it's all the y values above the line for any given x. So it'll be this region above the line right over here. And if that confuses you, I mean, in general, I like to just think, oh, greater than is going to be above the line. If it's less than, it's going to be below a line. But if you want to make sure, you can just test on either side of this line. So you could try the point 0, 0, which should be in our solution set. And if you say 0 is greater than 0 minus 8, or 0 is greater than negative 8, that works. So this definitely should be part of the solution set. And then you could try something out here like 10 comma 0 and see that it doesn't work. Because you would have 10 minus 8, which would be 2, and then you'd have 0, and 0 is not greater than 2. So when you test something out here, you also see that it won't work. But in general, I like to just say, hey, look, this is the boundary line, and we're greater than the boundary line for any given x. Now let's do this one over here. Let's do this one. The boundary line for it is going to be y is equal to 5 minus x. So the boundary line is y is equal to 5 minus x. So once again, if x is equal to 0, y is 5. So 1, 2, 3, 4, 5. And then it has a slope of negative 1. We could write this as y is equal to negative 1x plus 5. That's a little more traditional. So once again, y-intercept is 5. And it has a slope of negative 1. Or another way to think about it, when y is 0, x will be equal to 5. So 1, 2, 3, 4, 5. So every time we move to the...
That slope right there, negative 1, we would have started right here and we would have went down 1, left 1, down, or right, down, right, down, right, down, right, or up and left. Up and left. So let me do it.
Right 1, we go down 1. So we have a negative 1 slope. So it will look...
Is it going to be dotted or solid? Why is it going to be dotted? There's no equal sign on here.
It will look like this, and once again, I want to do a dotted line. I want to do a dotted line because that is our dotted line. And I'm doing a dotted line because it says y is less than 5 minus x. If it was y is equal to 5 minus x, I would have included the line. If it was y is less than or equal to 5 minus x, I also would have made this line solid. But it's only less than. So for any x value, this is what 5 minus x. 5 minus x will sit on that boundary line. But we care about the y values that are less than that. So we want everything that is below the line. And once again, you can test on either side of the line. 0, 0 should work for this second inequality right here. 0 is indeed less than 5 minus 0. 0 is less than 5. And then you could try something like 0, 10 and see that it doesn't work. Because if you had 10 is less than 5 minus 0, that doesn't work. So it is everything below the line like that. And like we said, the solution set for this system, are all of the x's and y's, all of the coordinates that satisfy both of them. So all the shaded in purple satisfies the second inequality. All the shaded in green satisfies the first inequality. So the stuff that satisfies both of them is their overlap. So it's all of this region in blue. Hopefully this isn't making it too messy. All of this region in blue where the two overlap, below the magenta dotted line on the left-hand side and above the green magenta line. That's only where they overlap. So it's only this region over here, and you're not including the boundary lines. Graph the solution set for this system.
All right, so go ahead and get your calculators out, and we're going to practice again, drawing these in on our calculator. make sure you got your calculators out. Now, he just did the two equations. What were the two equations he just did? Y is greater than x minus 8. And he did y is less than, it started out with 5 minus x, but that's the same thing as negative x plus 5. Right, so we're going to put these two in our calculator just to show you what it looks like on your calculator. So go ahead and go to your y equals. Clear out anything that you have in there. And remember, we're going over. We're going to move our cursor over here because that top one was greater than. So we're going to use that left arrow key. And I'm going to hit enter until I get to the greater than. Right, so that symbol right there is the greater than. Yours won't come up looking exactly like this, but it'll come up with part of it. All right, so here's the greater than. You come on in. I'm supposed to have a comment. Oh, go ahead. Here's the greater than symbol. So you're going to do the greater than. Oh, is it okay? Come on. There we go. So yours should look like that, the greater than symbol. So if you use your left arrow key, and then when this line right here is flashing, hit enter until it has this symbol right here, the greater than. So once you get that, go on back over and put in, what was that one? X minus 8? Yeah. X minus 8. Now we're going to do the same thing down here. This one was, it doesn't matter how it is written in there. We can do 5 minus x, but I will put my cursor over here on the other side, and I want this one to be less than. So you're going to hit enter, and for yours is going to look a little different than mine. You want the symbol that is less than, which looks like that one. The bottom of it. So you're going to hit enter over and over until you get that less than symbol. Okay, so you should have a, down here. You have a greater than up here, a less than down here. Now I have no idea what my window's on, so I'm just going to go zoom 6 and get that standard window in there, and it should shade it for me. So there's the first one, the greater than x minus 8. There's the second one, the 5 minus x. And if you notice, here's that same area that he had on his graph also. Okay, so your calculator is going to give you an idea of where it's shaded. But you got to know how to put it in there. You got to know how to graph it. Did everybody get this one? Check with each other around your table. Make sure you got these things. Good? All right, so now, on this first one, it says, what inequality is graph on the coordinate plane? So in this problem, they gave you the graph, and you have to come up with the equation. Well, in y equals mx equals b form, we need the m and the b, right? We need the slope, we need the slope, and we need the y-intercept. Well, where does it cross the y-axis? It looks like, let's just say for posterity's sake, negative 2.5. Would y'all be okay with that one? So negative 2.5, we're guessing. And we're going to pick 2 points. Now remember, how did we do the points? We picked a point and counted up and over, right? Is our inequality going to be greater than, less than, greater than equal to, or less than equal to? It's less than because it's below the line. Is it less than or less than or equal to? So it's less than because it's dotted, correct? Okay, so down here they've got, there's actually, I didn't want to use this one because they've got a 1/3 here. We guessed 1/2, and it was really 1/3. But remember, you'll have 4 equations, 4 answers to choose from on there. I just want to make sure you understand why it's below the line, why it's a dotted line, and the other stuff we've already been over. Now here's one where it talks about we're graphing the different systems of equations. So there's 3 of them right here. This is a vertical line. X is greater than or equal to negative 5. You can't graph this one on your calculator. You cannot graph a vertical line. We've talked about that over and over. But that vertical line is this one right here. X is equal to negative 5, but they've not shaded it yet. They're just doing the graphing the line. Now this one, where does this one start? Starts at negative 1, and then it goes up 1, left 1, up 1, left 1, right? Or down and right, down and right. Where does this one start? It starts at negative 1, and it goes up 1, right 3. Up 1, right 3. So that's where they got these 3 lines. Why is this one dotted? Doesn't have equal to on it. All right, then they went through and shaded. So they shaded the vertical line. It was greater than, so it's going here. Here's the vertical line, the blue one, so they went this way. The red line was less than, so they shaded it below. The green line was greater than, so they shaded it above. So your solution is this gray shaded area where they all intersect. Okay? Now, on your, that's all I have on here. On your homework, or what you're going to do here in just a minute, let me close this out. Remember, you're going to have, like I said, you're going to have a slope-intercept equation where it's in this form, y equals mx plus b. You put a point at the b, so put a dot at b on the y-axis, and then you use, and you've written this many, many times, you're going to use your slope, and let's say find another point. That should look familiar, correct? Find another point. All right, now, in order to put it in that calculator, you can't do standard form in the calculator. So how did we go from standard form to slope-intercept? How did we go from this form to this form? What did we do first? We brought the AX over to the other side. So you bring over AX. Well, that's an O. Bring over AX. Remember, you're going to add or subtract if you know what the sign is. Then you're going to divide by B. So you do that one, then you divide by B, whatever that is. So just as an example, if I had 2x plus 3y equals 6, that 2x is positive, so when I bring it over, it becomes negative. So I'm going to have 3y, and I'm going to put the x first. So negative 2x plus 6, and then when I divide everything by 3, those cancel, and we get y equals negative 2/3 x, and 6 divided by 3 is 2. So I would put that in my calculator. Remember, when I put a fraction in, what do I have to do on the calculator? Put a parentheses, and I would, well, if I had two of them, I would put the other one in, and then you're going to intersect. Now, all of this is everything we've already gone over. So here's what we're going to do right now. As a, let me see.